Hello buddy, welcome back to my channel. In today's video we're going to be going over welding. I know you guys have seen me do a whole lot of welding on this channel, and I'm sure you guys have some questions on how to do welding. Maybe you've never done welding before and stuff like that. So what I want to do is I want to get a little more detailed into the aspect of welding, what kind of welders are out there, what kind of welder that I use here in the shop, versus say something you see on a much larger operation and stuff like that. So hopefully by the time I get to the end of this video, any questions that you have will be answered, and you might have the confidence to get yourself a small welder and take on a little small project. Let's get to it. This video is going to be a whole lot of talking. I'm going to give you some time slots so you can fast forward to the areas of most interest. Okay, so I'm going to go ahead and talk about some of the welders that are out there. You have your stick welder, you have a MIG welder, you have a gasless welder, you have an aluminum welder, and you have a TIG welder. Then you also have brazing. Now, you'll probably never ever use brazing to build a Halloween prop, so we're not going to talk about brazing in this video. Now, you also notice I didn't use the word wire feed in any of the descriptions on there, because the term wire feed is exactly what it implies. It means that whatever machine you're using feeds the wire to the end of the wand for you, so you're not doing it manually. So you can get a wire feed in a MIG, gasless, or an aluminum application welder. So that has no bearing on the actual machine itself. That just describes what that machine does, essentially. Now, I'm going to give you a quick description on how a basic welder works. Now, they're a very simple design, very low-key type of system. Pretty much kind of look at it as a car battery. Have you ever seen somebody, or probably done it yourself, where you accidentally touch the positive and negative terminal together on a car battery and you get a huge arc, big spark? Depending on what you touch on there, a lot of times it'll get extremely hot, it'll melt, and that kind of stuff. That's pretty much the same basic design behind a welder. A welder pretty much has a transformer inside of it. You have your ground wire that you clamp onto your material, which essentially is kind of like your negative side. And then your wand is essentially your positive side. So what you're doing is when you're actually touching the wire for the welding aspect itself to the metal of the material, you're essentially like touching the negative side of the battery. What that does is that heats that material up really quick, really fast, and essentially liquefies it. And as it liquefies it, that's what causes it to liquefy and burn itself onto the metal, the material, whatever it is you're welding together, creating your weld. All right, so next we're going to talk about the welders themselves and how they work. We're going to start with the stick welder first, or also known as a fuzz box. Those are probably the most simple design welders out there. Essentially, all they are is a metal cabinet with a transformer inside of them. They have a power cord that goes out of the back. They're generally a 220 machine, predominantly a 220 machine. And then you have your two leads that come out. One of them is going to be your negative side, and the other one's going to be essentially your positive side. I have a couple little things down here just to give you a quick demonstration of what I'm talking about. So your negative side is going to have a clamp that's going to either look like this, and they do have different style clamps and stuff like that. You just open it up and you'll clamp it onto your material. Any material that you're welding on, for the best results, you always want to make sure your metal's clean. So you're going to want to grind it, sand it, whatever the case may be. So this way you're literally welding on the metal itself and not over any kind of like dust, rust, or anything of that nature. Then you're going to have your other half, which is going to be your positive side, which is going to have a thing that's going to look a little bit like this right here. Your wire's going to come in the bottom here. You squeeze this right here to essentially open up that top. When you open up the top, that's where essentially you're going to put your welding rod. Now, this isn't actually a welding rod. This is just a piece of wire I had. But essentially, your welding rod essentially is going to be a rod that's going to look a lot like this right here, but it's going to have like a flux kind of coating over top of it, which is a lot of times either a white or sometimes a grayish color. What that does, that shields it from the oxygen as you're doing your welding. There'll be some numbers towards the back side right here. Those numbers are going to correspond what that particular rod is used for, whether it's burning like half-inch material or something like that. And then essentially what you do is when you're ready to weld, you're going to stick it on your material. You're going to scrape enough until you scrape enough of that flux off the end of it. So this way your metal on metal, it's going to start burning that metal, and you're just going to go back and forth, or half moons, or whatever you're going to do. And obviously as you do it, the rod's going to get shorter and shorter as you go. So the biggest trick to a stick welder is learning your speed, because if you don't go fast enough, it's going to constantly mess up on you. It's going to get stuck and all that kind of stuff because you're breaking the contact because it's not going fast enough. If you try to go too fast, you're going to make giant puddles that aren't going to look really good. So there's a balancing act of essentially how fast you move this down to how fast it's melting your material, and that's going to be based on the voltage that you have your machine set to. So that's pretty much a stick welder right there. So the next welder is probably the one that most people hear the name the most, is MIG. A MIG welder is essentially a wire feed system that requires gas to use. So that's what this machine right here is. This one's set up as a MIG welder. So you have to have a big gas tank like this right here, a regulator, that goes on there, because you have to regulate how much gas goes into it based on the voltage you're running and stuff like that. And then you're going to have your wand, which is going to be right here, and this is essentially where your wire is going to come from. So your wire is going to run through this cable and it's going to come out the end right there. So when you press this trigger right here, what's going to happen is as the wire comes out, it's also going to shoot gas out with it. What that gas does, that gas shields the wire from the oxygen, and that's what gives you a much cleaner weld, a better weld, a stronger weld, and stuff like that. But the biggest killer for these welders right here is air. So if you're welding something outside and it's windy, it can mess up your weld. If you're inside your shop and you have a whole bunch of fans blowing on you because it's hot out, it's going to mess up your weld. So these are very temperamental when it comes to doing welding with a gas welder. You pretty much have to have pretty much almost no air blowing around you. The metal has to be clean. I mean, you can't even have even a slight bit of rust on that metal, or it just won't get a good contact. So these are a little more temperamental, but they do a much better weld in the end as far as cleanup and stuff like that. The welder that I predominantly use here in my shop is this machine right here. Now, if you look at these two machines, they pretty much look identical. They pretty much are. They're both a wire feed system, but this is what they call a gasless flux core welder. So this welder right here doesn't require any gas or anything like that to use. And it's going to be pretty much the same system. You're going to have your negative cable you're going to clamp on your material, and then you're just going to have a wand. You press the trigger, the wire starts to come out, it welds. When you're done, you shut it off, you're done. This is probably the best welder for a DIYer, a first-time person wanting to learn how to weld and stuff like that, because these are very simple to use. They're very simple to operate. You don't have to worry about having no air around you, having your gas, making sure that your regulator is set up properly and all that kind of stuff. You literally just turn the machine on, make sure your metal's clean, press the trigger, run your weld, shut your machine off, you're done. What I'll do in just a minute, I'm going to describe the differences between the two wires between these two and what makes them different. But we're going to finish talking about the machines first. Your next one is going to be your aluminum welder. Now, your aluminum welder is going to be a lot like this machine right here. The only difference is instead of your wire being inside the machine, like that right there, where the wire feeds through your cable into your machine, your spool is actually going to be on your handle, because aluminum is so much softer. Trying to run aluminum through a 4 to 5 foot cable isn't going to work. So everything will be all electronic, until you get here. So you're actually going to have your spool, which is going to be generally a 2-pound spool. This is a 10-pound spool. Generally a 2-pound spool, which is essentially this size right here, is going to be sitting on top of your gun like that right there, feeding right there, only going through about maybe 6 to 7 inches worth of hard line. And that's going to lay well. But the downside with aluminum is kind of the same as the MIG. You got to have gas for it. If you don't have the gas, it's not going to burn properly, and you're not going to get a good weld with it. So for an aluminum welder, you got to have essentially a spool gun, essentially is what they call it, and you got to run gas for it. So I don't do a whole lot of aluminum stuff, just because it's a little bit more of a pain in the butt. But that's essentially your aluminum welder is pretty much this machine right here with the different kind of gun essentially. Your last welder is a TIG welder. Now, that's probably the most complicated welder to use, at least until you get really used to it. And that's the reason why is because it could be a 3-part system to use a TIG welder. You not only have a foot pedal that you have to press to regulate your voltage, then you're going to also have your thing that they call a torch. Your torch is the part that's going to have like this nice fine point piece at the very end, and that's what's going to get red hot, and that's what's going to melt your material. And then you got to have your rod. So if you ever done soldering where you're soldering a couple pieces of wire together, you have your soldering iron, and then you have your solder, and you're kind of going back and forth like that. A TIG welder is a lot like that. Now, depending on the gap that you're working with, a TIG welder, a lot of times you can just melt your metal and stuff like that and not even have to use a rod. But sometimes, depending on what you got to do, you might need a rod. So now you got to use your foot to regulate a pedal, you got to regulate your torch, and then you got to have your rod. And you got to make all 3 of those things work together to generate a really good weld. What TIG welding is really good for is sheet metal work. It's great for like restorations, hot rods, things like that, because it'll do a good weld, but it doesn't put off a lot of excess heat, so you don't get a lot of warpage and stuff like that of your materials. So using a TIG welder for like a Halloween prop really is not ever going to be a necessity unless you already have a TIG welder and you're great with a TIG welder and you love using it. But that's not something I would invest in to build a Halloween prop. If you're looking to get first time into welding and you're looking for something that's going to be an easy machine to kind of learn how to use and stuff like that, especially if you're doing small welding projects, a Halloween prop, or fixing the bracket on your lawnmower or something like that, your gasless flux core style welder is going to be the easiest DIY welder that you're going to use until you get really used to it. So the next part of this video is going to be me going through and showing the difference in the wire, how to reload one of these machines, and then we're going to start doing a little bit of welding and show you the difference in the welding. So let's get to that next. All right, so before we start generating any sparks or anything like that, let's go ahead and talk about the machine itself, how it operates, and essentially how you use it. Now, this information is going to be identical whether it's a gas machine or a gasless machine. The only difference is if, say, I was going to run gas on this, I'd have to put a different kind of wire in it than what I'm currently using, and obviously get the tank and the regulator. So generally, they're all going to have this access panel on it, and on the access panel is going to have some general information on here as far as what voltage you want to set it to, what speed you want to set it to based on the thickness of material that you're welding. And then if your machine is set up to do both gas or gasless, you're going to have also a description on your polarity. You have to actually adjust your polarity, whether it's going to be gas or MIG. But if your machine you buy is strictly a gasless machine only, you're most likely not going to have these settings right there. My machine can do both, but since I have two welders, I already have one set for gas and one set for non-gas, so I never mess with the polarity aspect of this machine. Then when you get into your cabinet, you're going to have your spool of wire, you're going to have your motor drive system for the wire feed aspect itself, and then you're going to have right here, this is my polarity setup for my machine, just two little wing nuts and two wires. If I was setting this up for gas, I would essentially just put this wire right here, up here, and this one down here, and that's all you got to do for your polarity setup. So the polarity is very easy to change when you want to change it, depending on your machine. Now, generally, most of these machines will come with a 2-pound spool, which essentially is this size right here. I generally will buy the 10-pound spools, but if you're going to use a 10-pound spool, you have to have this little adapter right here. Depending on the machine you buy, sometimes that adapter will already come in the kit when you buy your machine. If not, a lot of times you can pick these things up on Amazon, probably eBay and stuff like that. It allows you to put a 10-pound spool in there. Obviously, a 10-pound spool is going to cost more than this right here, but when you think about it, this is only a 2-pound spool, and that's a 10. It's going to cost me more to buy 5 of these than it's going to cost me to buy 1 of these. And it's going to give you the same amount of time frame as far as work time, but you're not going to be replacing this thing as often. So the 10-pound is a much nicer thing to have in there as long as your machine will accept it. Some machines are a little bit smaller, might not be able to accept a 10-pound spool. So you just have to check your manual to see if it can accept a 10-pound spool before you invest in stuff like that. Now we're going to talk a little bit about the clamp and the wand real quick. So your clamp is just, kind of like this right here. Now, like I said, it's a little different shape than the one I showed for like the stick welder thing. But pretty much you see where you have the little copper piece right there, the wire's attached to it. You just clamp it onto your metal, make sure your metal is clean so you get a good contact. That's all there is to that right there. Then you got your wand, like we talked about before. You have your trigger. You have the end where the wire is going to come out. And pretty much that's all there is to this right here. Now, what I want to do is I want to kind of turn this machine on real fast and kind of show you the wire feed aspect real fast. Then we'll talk about some other things. So let me go ahead and adjust my speed really fast so you can see it really good. So once I press that trigger, you're going to see this start spinning. This you might be able to see that in the camera. That starts spinning where it's actually pulling the wire through, and then it's going to come out here. And that right there is pretty much the whole basic aspect of a wire feed welder. Now, over time, as you're doing your welding, that piece inside there that the wire is actually coming out, that will need to be changed after a while of a lot of excess welding, so with that. To change that, you just unscrew this piece right here. We're going to pause for 1 second. If you were just welding with this before you were going to change your tip, make sure you're wearing a set of gloves. The end of that wand is going to be extremely hot and it will burn your fingers. And then this piece on the end here, that unscrews also. You just get a pair of pliers, loosen it up. You just unscrew that. You take that right off. You get yourself a new one. You can buy these in little packs of like 5 or 10, stuff like that. You just slide it back on, run the screw in. Now when you snug this up, you ain't tightening a lug nut on a car. You just a little snug. That's all you got to do, and that's all there is to changing that end piece right here. Now on these machines, you have 2 general size wires. You have a .030 and a .035 wire. Generally on these smaller machines, you're only really going to ever want to run your .030 wire. The .035 is really good for if you're doing something really heavy duty. Like when I was doing the forklift and I was welding the fork area where I had the pulleys and all the bearings and all that stuff, I used the 3.5 wire for that because I can burn it hotter and get a better weld, a stronger weld for something like that. But for basic general welding and stuff like that, like you're welding a bracket on your mower or like some Halloween problems, the .030 is really all you're going to want to use for that. And when you go to the store to buy the wire, What you're going to see on them is like this one right here. You can actually see where this actually says gasless flux cord wire. And now this is the 3.5. You know, this is what I used on the forklift. But you'll also see ones that are right here. It'll say 0.030 in gasless. Or sometimes it might not have the word gasless on it, like this one right here. You notice this one doesn't say gasless on it, but it says flux cord. Flux cord and gasless are the same thing. So if you don't see gasless, this is what you're going to want to look for where it says flux cord. Now, if it's a MIG welder, it'll say MIG wire on there. That's how you can determine the difference between the two. And I wish I had a spool so I can kind of show you a little bit better. But what another thing you're going to notice right out the get-go, like when you're looking at these things on the shelf, is the gasless. See how the wire almost looks is a nice silver, you know, almost like chrome-looking kind of color. That's the shielding that protects the wire from the oxygen. That's what gives you your flux cord portion. If you're using a straight MIG, this is going to look like copper. It's going to look like a roll of copper wire, essentially. And that's the first indication that you're going to see whether it's going to be gasless or non-gas is the color of this wire right here. It's either going to be a copper color or it's going to be like the silver color you see right here. Now I'm going to kind of turn the machine a little bit real fast to kind of show you the front of the machine real quick. All right, so here's the front of my machine. Now, just about every machine is going to generally have two forms of dials on there. Some of them are just switches, and some of them are actual turn dials like this one right here. Now, this is where you're going to have your voltage setting and your speed setting. Now, mine setup is just A, B, C, and D. A is obviously my lowest voltage, which is going to be great for really lightweight material, like say I'm doing a little bit of sheet metal on a car or something like that. That's going to be the lowest voltage that I can put out of this machine. And then here's my speed control for my wire feed. Now on mine, if I have it on A, my speed needs to be just below my 2. If I put it on B, which is going to go with a little bit thicker metal, then I bring my speed up just a little bit more. If I'm going to C, do it again. If you go to D, you go even higher. You're never gonna, the only time you're ever going to run that speed all the way up to 10 is when you're reloading your wire, because it's just going to feed a little bit faster into your wand so you can get it done quicker. But this machine right here, even on my hottest setting, I never even get it to 4. Because any higher than that, I'm not going to get a good weld. What's important about this part right here, almost dropped my phone on you guys. What's important about this part right here is speed versus voltage. So essentially, if you don't have your speed adjusted properly to your voltage, you're not going to get a good weld. So if I have say I have this thing set on C, and I have my speed all the way down on like 1 something, maybe 2, what's going to happen is that's going to come out of the gun too slow for that voltage. And it's going to burn the wire and melt it faster than it's going to come out. So it's going to constantly stop on me. It's going to feel like I'm constantly losing contact because I'm not going to have a consistent contact. It's almost kind of like taking a garden hose, and you know how like if like you spray it after you get a longer distance, when the water stream starts to break into more droplets, you see just little droplets hitting the ground instead of like a solid, you know, volume of water. That's going to be the kind of same thing as this right here. You're not going to get a good consistent bead. Now, if you have your speed too fast, what's going to happen is this is going to hit the metal, and it's not going to melt as fast as the amperage is giving it. So it's going to give you kind of what they call like that popcorn effect, where it's just going to be a bunch of little pew, 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 kind of thing, and it's not going to give you a good weld at all, because it's not really getting any kind of bite into the metal. It's more or less just something on the surface, and it's not going to do you any good. It's not going to be strong, and it's going to break. So learning your speed to voltage is extremely important to get a good weld out of one of these machines, or any machine essentially. So now that we got a lot of that basic information out of the way, I want to do a couple little welds just to kind of show you. And then before the end of this video, I want to show you how you're going to reload one of these things. Mainly because the very first time I did it, I ended up actually wasting quite a bit of wire, because they're kind of when they're spooled up, once you cut that tension out there, they tend to like almost like an old fishing pole where they just knot up and stuff like that. So I'm going to show you that before the end of the video, but let's go ahead and start making some sparks. All right, so before we do any welding, let's talk about some of the dangers and some of the stuff you need to do to protect yourself while you're doing your welding project. Obviously, the #1 danger when it comes to welding is flash burns and skin cancers. So you always want to make sure that you protect yourself from the light that comes from a welder. Numero uno, your eyesight. You really want to have yourself a good quality helmet that is either an auto darkening or even a non-auto darkening. It really doesn't matter, but you definitely want a nice full face helmet to protect your eyesight, because it can burn your retinas and cause blindness. Your hands are one of the closest things to what you're welding. So they're subject to the heat and the light more than just about anything else on your body. So you're always going to want to have a good set of gloves while you're doing your welding. You also want to protect yourself from burns. Not necessarily flash burns, but obviously if you touch a hot piece of metal, you also don't want to give yourself a 2 or 3rd degree burn from touching a hot piece of metal. You also want to protect your arms whenever possible, mainly for the fact that you obviously don't want a bunch of flash burns on your arms. So you can buy jackets where they're literally just a set of sleeves to protect your arms. Or what I've done is I took a long sleeve shirt that I put on and I cut the whole rest of the shirt off, and it's literally just the sleeves. Because really all you just need is some kind of barrier between your bare skin and the light to help protect yourself. The other thing you want to also be super cautious about is particular metals that you're going to be welding that put off toxic fumes. Galvanized is one of the worst ones you can do. When you're welding galvanized, it will put an off-gassing that's very essentially potent, very poisonous, that can cause lung cancer and respiratory issues. So if you're going to do any kind of welding with galvanized, make sure you sand off the galvanized coating in that area prior to doing any welding. Other metals can still put off-gassing, especially if it has any kind of paints and stuff like that on it. And if you're welding in an area that's kind of closed up a little bit and it's generating a giant cloud around you, that can be very harmful. So you're always going to want to have some kind of cross breeze just to kind of help keep a little bit of ventilation going. Like we said earlier, depending on what welder you're using is going to determine how much air you can really have blowing around you, so it doesn't mess up your weld. But you do want to have some kind of cross ventilation to keep that cloud from essentially surrounding you, causing respiratory issues. Now that we got some of that out of the way, let's go ahead and start tinkering with a little bit of welding and show you what to do. All right, now I'm going to kind of show you just a couple different welding patterns, I guess you can do while you're doing your welding. Now you also want to make sure that your wire is only anywhere from 1/4 to maybe 1/2 inch max past the end of your gun while you're doing your welding. Any further than that, you're going to lose contact. Any closer, you're going to burn it into the end of the tip and it's going to get stuck inside there, and then you got to get it unstuck by unscrewing the nozzle and all that kind of stuff. So keeping anywhere from 1/4 to 1/2 inch max is where you're going to want to kind of be with your welder, especially when you're using gasless. So one of the techniques is the small circle thing, where what you're going to do is as you're welding, you're going to do like these little teeny kind of like circles like this, you know, kind of close to each other. That's going to give you like a bit of a blob looking kind of weld, you know, kind of deal to it. So this way it actually looks a little bit more like a solid bead kind of thing, not so much as like that roll of dimes kind of look that a lot of people talk about. To do kind of like the roll of dime thing, you're going to be doing kind of like half moon kind of shapes. So what you're going to do is as you're welding, you're going to kind of go back and forth like this, but you're going to curve it back up onto itself while you're doing it. So you're going to go back and forth like this. What that's going to do is that it's going to generate that kind of like that roll of dimes kind of look, you know, that you hear people say. And what I'll do is I'm going to do a couple little demonstrations to kind of show you what those two beads look like when you actually burn it that way. All right, so what I'm going to do right here is I'm going to show you the difference between my speed being too slow, my speed being too fast, my speed being pretty much just right, and then I'm going to show you like the half moon and then the slight small circle technique, so you can see all the different welds on there and what they all look like based on, you know, the differences of the settings in the machine. So let me go ahead and put a piece of glass over the phone so you can see the welding process, and it also protects my phone. All right, so here we go. This is too slow. This is too fast. This is pretty much right where it needs to be for the correct. Now this is the half moon. And this is your small circle. All right, so let's go ahead and talk about these beads and the differences between them. Now, the first one is the one where I said I'm going to set my speed too slow. So essentially what's happening here is as the wire's coming out of the end of this gun, what it's doing is it's melting that wire right off until it gets back to here in that area. And what you're getting is you're only getting like that wire touching it in little spurts as it's slowly feeding itself out. And that's essentially what you're getting right there. You're never going to get a good bond with that. You're never going to cover any kind of real surface or anything like that. So that's where it's way too slow. This right here is where you have your speed a little too fast. So what's happening here is as the wire's coming out, it's not melting as fast as it's coming out. So you're getting big blobs that are kind of building up. And it's also causing the wand, as the wire comes out, it hits and the wand gets pushed back. And as it pushes back, you're moving it away from it, creating these little hollow cavities in between each one of them, essentially creating that, what they call a popcorn kind of effect. And essentially that right there is going to do nothing for you. It's not going to bond to anything. This next one is the one you really want to have. This is where your speed and your heat are pretty much right about on par with each other. You see there's no breaks in it. It's very consistent. It's very, solid. That's going to be a really good connection. That's essentially what you're going to want. Now, these two are the two patterns. Now, I know it's not super pretty, but, I'm just mainly just doing some demonstration stuff for you guys. This is essentially like your half moon kind of crescent shape right here. This is going to be good for heavy material like your welding, like say like on the forklift area, where I got to make sure I get a good bond, very good solid connection. This is going to be good because it's going to cover more surface and give you much more bite. This is like your little circle one. This is going to be great for small, lightweight stuff because since you're not really looking to bear a whole lot of weight, the weld can be very isolated to where it needs to be. So this little circle one right here is really good for that. While I'm doing all the Halloween stuff, this is pretty much the one that I use for all my stuff because it's still going to be nice and strong, but you're not getting too carried away like you're doing right here because you're not welding anything super big or super solid. So that's really the differences between essentially your speed to your heat controls to the different kind of patterns that you're going to do depending on if it's lightweight material or heavy gauge kind of material. So let's go ahead and start welding some pieces together. All right, so what I'm going to do now is I'm just going to show you just some quick welding. Now this right here is the metal that you see me use on a couple of my Halloween props, the animated angel and stuff like that for the armature. It's just a piece of square stock, 16th inch wall. Nice thin stuff. You can weld this stuff really good. It's still lightweight, nice and strong. So what I'm going to do is I'm going to take that and I'm going to weld a piece onto it like this. We're just going to do a little burn on there, just kind of show you real fast. And then I also want to show you the importance of your temperature versus the thickness of your metal. So I'm going to put this one on here and I'm going to have my temperature too high and you're going to see where I'm actually going to burn a hole right through that metal because my temperature is too much for it. So let's go ahead and put my clamp on here. Now with this only being 16th inch wall, this one right here, this is where I'm going to run it on my B setting. Let's go ahead and get the gloves on, protect the phone. Now what I'm going to do is I'm going to do a couple tacks just to hold it in place so I can let it go. So this way I can use both hands on my wand for better control. Now if you look at the end of the gun, you can see I'm sort of doing like the small circle movement because this is lightweight material. All right, so now we got that. Now a couple of things you're going to need in your arsenal as far as tools is a hammer that kind of looks like this right here. What this is going to be for is if you have excess slag, you can knock it off right there. Or just a nice good wire brush. So you can wire brush your material. So this way you're getting all the stuff out of there for painting purposes and stuff like that. Now one thing that you have to keep in mind when you're doing welding is since it is generating heat, what it can do is as I'm welding on this side, it will actually cause the metal to move. So if you want to make sure that everything stays nice and square and stuff like that, having a clamp is going to be best. If not, you got to weld in a sequence. So like say I put like a tack on this corner and a tack on this opposite corner. So I'd actually tack it, just a little zap, zap, tack it. What that's going to do is that's going to keep my material from wanting to move this way or this way. Now, once I got those tacks on there, then I can go ahead and I can burn it in, burn it in, burn it in, burn it in. And that's going to keep my material as straight as possible without moving all over the place. And you can always use a speed square or a framing square to make sure that everything's nice and square and stuff like that. But like right now, just burning one end like that, it's going to cause it to want to pull to that side. So you want to do tacks in a few spots, and those tacks will lock it in position so you can burn it completely in. So now what I'm gonna do is I'm gonna do this real fast. So what I'm gonna do is I'm gonna put this on here. I'm gonna set my machine extra, at a hotter setting than this metal can take. And you'll actually see where it'll actually burn a hole right through the metal. Now it is fixable. So if you end up doing that, then you just come back with a much lighter setting and then slowly fill that hole in from there. So, but let me show you that real fast. All right, so you ready? So you can see where I put the setting so hot that see where I literally just burnt that pipe to the point that I didn't even actually get it to bond to anything. So pretty much how I'd have to fix that is sand that back off. Obviously, I might have to cut a new pipe. If I can salvage my pipe, just put it on a lower setting, and then I can fix that. So what I'm going to do is I'm actually going to leave it alone. I'm going to put it on a lower setting, and then see if I can essentially salvage that piece right there. So let's go ahead and set that up. Now what I'm going to do is I'm going to work my way around that material. Because right now, obviously, heat is going to be our enemy. So okay, so now you can see where adjusting my heat and my voltage has now made me to where I can bond in there. But now obviously you can see my weld is a little bit bigger than it would have been, mainly due to the fact that obviously I had to build it out further to fill the hole in and to get my bite on there. So even though you accidentally overheat it and burn a hole in it, you can salvage it just by readjusting your machine and slowly just kind of working it back in there. So all right, so let's go ahead and do one more little sample. All right, so those first two examples were for lightweight material, what you're going to encounter for like a Halloween prop and stuff like that. What I want to do is I want to burn something a little bit heavier now, just to kind of show you burning something a little bit thicker and stuff like that. Depending on what you're making, if you're making yourself a heavy-duty stand or something like that, you might have to get a little bit thicker material. When you start getting into thicker material like this right here, sometimes it's always a good idea to have a little bit of a bevel where you're going to be doing your welding. So this way you get the material inside a little further, and you'll get a much stronger bond and a better connection. So what I'm going to do is I'm going to put this on here. I'm going to set my machine a little bit hotter setting. And then what we're going to do is as we go down around this, we're going to be going probably just a little bit slower than we were with the other material. And we're going to kind of walk our thing back and forth a little bit to really get inside there. So this thing ends up becoming essentially one solid piece when it's done. Let's go ahead and get the gloves on, protect the phone, and we're going to get this one burnt in. Now what I'm going to start off with is a couple tacks to hold it in place so I don't have to hold it the whole time. So let me do this taxer first, and then we'll burn it. All right, here we go. Now, if you look at the end of the gun here, you can see I'm doing that half moon kind of crescent movement because I want to get a good bite on this one. All right, so I got that burnt in, and to kind of give you an idea of how hot that can get. So that's where the importance of gloves is going to be, because if say you were to touch that right now, you'd end up with a 3rd degree burn, instantly. So there we go. So that's pretty much what you're going to do for burning something a little bit heavier. And then right here, watch, you're going to see where I'll knock off the excess slack stuff. Wire brush it. And there we go. So now we have a nice, good, solid bond connection that's going to keep that from coming off. All right, so I want to show you guys just a little bonus thing real quick that a lot of people don't really know about. Say you have a piece of material and say you have a big old hole that you drilled in or something like that, and now you want to get rid of that hole, you want to make it disappear. Now you could take your wand and slowly go around it and so with that and slowly burn that hole in, but what's going to happen is as that wire goes through the hole, it's going to slowly build out on your bottom side, and you're not going to have a nice clean finish on the bottom side. Now you got to get in there somehow and try to use a grinder and all that kind of stuff. You use a piece of copper, which you can already see I've done it before for issues. You take a piece of copper because the weld won't stick to the copper. Take it, clamp it underneath the hole where it's going to be because you want it to stay as tight as possible against it. Adjust my vice grip here. Now when I weld and I go around here, the copper is going to keep my wire from going all the way through where I don't want it to be. It's not going to stick to the copper and I'll be able to fill that hole in. Let's go ahead and show you that real fast. My ground hook to it. All right, so you can see where I got it welded and pull the clamp off. So you see where the copper piece just fell right off of it. My bottom side is going to be nice and flat, which I'll show you in just a second. The only thing I have to do now is, obviously all my welding is now mainly on the top. So I'm going to grind that down real fast. Once I grind that down, I'll show you that material top and bottom, just to kind of show you, how this is a really nice effective trick. So let me get this grinder real quick. All right, so let me pull this out of the vise real fast and show you. So now you see where my top is nice and flat, and so is my bottom. Let me take a wire brush real fast, kind of clean that stuff off the bottom so you can see it a little better. Now when you look at the bottom, the bottom is nice and flat. It's not protruding a whole bunch of wires into it. So that's a little trick right there. So if you ever have a piece of material you got to fill a hole in, use a piece of copper pipe, fill your hole in. All right, so before we close this video, I want to show you how to reload one of these machines because they can be a little frustrating and you can waste a lot of material if you don't hold on to it properly. So every one of them is going to have some kind of tensioner that's going to go down to the little drive motor for the wire feed aspect. These generally would just flip over to the side and you have this little thing you lift up right here. I usually lift this back up out of the way because there's a little hole right here and that's what you have to feed your wire through. Now most spools are going to come where the wire is kind of bound either in the end of the spool to a hole or sometimes they're taped. Now I'm going to be doing a 2-pound spool for this demonstration because this is probably going to be the one you're going to be having. So what you do is make sure when you find your end, put your thumb on there and hold that. Don't let that thing ever go. Because have you ever seen like a bait caster fishing reel, like if it does that massive rat nest if it gets let go or something like that? These will do the exact same thing. You'll never get it wound on there nicely again, and you end up wasting a lot of wire. And this stuff is not getting cheaper. So what you're going to want to do is hold on to that really good. Don't let it go. Put it on your machine. Now this one has a 2-part system for its lock messing. Yeah, this one piece right here has like a keyway on there. What that does, that keeps that from spinning. Then you got your wing nut. And what you're going to do is you want to make this tight enough to where this doesn't spin by itself. Because you want to be able to do all the control of it until you get to a certain point. Make sure your wire is nice and straight. What you're going to do is you're going to feed it through here. Then you have to push down on it to get it into the secondary hole, which is the hole that's going to go into the wand. Sometimes it can be a little tight getting in there, depending on the wire. If the wire's a little bent or whatnot, there we go. Then you're going to flip that back down, put your tensioner on there. Now once you got that on there, then you can go ahead and loosen this up a little bit. Now as you loosen it up, you'll see that spool wanting to turn by itself. See how it did that right there? That's where you kind of want to have it right there, where it's loose enough where it almost wants to spin by itself, but not loose enough where all of a sudden it does like a rapid spin on you. And you're going to want to leave it there. Then you're going to want to pull the end of your tip out, set your speed at full max, and then just let it push itself through that cable until it pops out the end here. Okay. And then what you're going to do is, since this is the 3-5 wire I'm using, I'm going to have to use a 3-5 tip. So once you got that, slide it over top of it, screw the tip in, snug it up, put your end on there, readjust your speed to where it needs to be, close your door, and you're ready to continue welding. But like I said, if you don't hold on to this wire right here while you're putting everything in there and all that kind of stuff, that thing will just rat nest really bad, and you're pretty much going to be throwing half of that reel away. So following that step right there will ensure that you're not going to lose any wire that you don't want to lose. Let's go ahead and finish this video out. All right, so that pretty much kind of wraps everything up. I hope this video is extremely helpful for anybody that, say, doesn't have a welder but kind of wants to get into it a little bit. I tried to touch a little bit on every aspect of welding, as far as the different kinds of machines out there, how each one of those machines work, how the basic machine, like say the one I use, works, as far as how you refill it, the settings on it, all that good stuff right there, the difference in the wires, stuff like that, and then a few different samples of welding something that's a little bit light duty to something a little more heavy duty and stuff like that. So in the end, I hope any of the questions that you had as far as when it comes to welding is answered, and you might have the confidence, say, to pick yourself up a cheap little welder off of, say, like the marketplace. I would suggest finding yourself something super cheap, especially in the beginning, and just get out there, get yourself some steel, and just start practicing with it. Welding is a really good thing to know, because you can do so much more with your prop building, especially when it comes to building, say, like ground breakers, metal armatures, stuff like that. So you don't have to stick with PVCs and 2x4s and stuff like that. You can make a much stronger armature that is going to be more lightweight, less cumbersome, and all that stuff by using small square stock that you saw me use in the video and stuff like that. So it's really a good thing to know and a good thing to kind of get a handle on, I guess you can say. So hope you guys enjoyed this video. If you guys have any suggestions on anything else you want me to get a little bit more detailed on, please let me know. I'll gladly make a video for you guys. We'll see you guys on the next one, and thanks for watching.